Hello. In a previous video, we looked at the layers of blood vessels. In this video, we're going to look at different events in the pacemaker potential. Okay, so some background information on pacemaker potential. Pacemaker potential takes place in the SA node, which is auto or rhythmic. This means that it self-regulates the potential. So what are the three main events in the pacemaker potential? The three main events in the pacemaker potential are slow depolarization phase of SA node, near midpoint of slow depolarization phase of SA node, and action potential phase, which includes rapid depolarization followed by repolarization. Okay, so let's take a deep dive into each of the events and what those events entail as per the ion movement. The first event is slow depolarization phase of SA node. During slow depolarization phase, there is slow influx of sodium plus ions seen as sodium plus permeability increases while K plus permeability decreases. The pacemaker potential is approaching the threshold. There is no resting membrane potential for pacemaker potential. The membrane potential is constantly increasing because of constant slow sodium plus influx. Okay, so this is a pacemaker potential diagram, and this phase over here is slow depolarization phase. The main things you need to remember in slow depolarization phase is that there is slow influx of sodium plus happening because of increased sodium plus permeability. The pacemaker potential is approaching the threshold, as we can see here. And the last thing you need to know is that pacemaker potential has no resting membrane potential. The membrane potential is constantly increasing. Okay, so these are the points for slow depolarization phase. Now let's look at the second event, which is near midpoint of slow depolarization phase of SA node. At this point, the T-type channels open, which causes calcium 2 plus influx. The T channels stay open for a short period of time, and the pacemaker potential continues rising towards the threshold. Coming back to the diagram, as we just said, at near midpoint of slow depolarization phase of SA node, we see calcium 2 plus influx, and this is because of T-type channels, and the pacemaker potential continues rising towards the threshold. Okay, so that's all for near midpoint of slow depolarization phase. Now let's move on to the last event, which is action potential. Now, as we said, action potential has two other events. That's rapid depolarization, which is followed by repolarization. Now, once the threshold is reached, action potential is initiated. L-type channels open, causing calcium 2 plus influx, and this is where rapid depolarization is seen. Coming back to the pacemaker action potential diagram, during this phase, L-type channels open, and this L-type channels causes calcium 2 plus influx. And this stage is rapid depolarization stage. Now the last event is repolarization. So during repolarization, the L-type channels, which are open during rapid depolarization, are closed, so no more calcium 2 plus influx, and K plus rectifier channels open. And as we all know, during a repolarization, K plus moves out of the cell. So K plus in this case moves out of the SA node. And this is what causes repolarization. Coming back to the pacemaker action potential, this whole phase is repolarization, and during that, the L-type calcium channels are closed and K plus rectifier channels open. And this K plus rectifier channels opening causes K plus to move out. So those were the three main events of pacemaker potential. Again, the first event is slow depolarization phase. Main thing you need to remember, slow sodium plus influx, no resting membrane potential seen, pacemaker potential approaching threshold, and the membrane potential is constantly increasing because of slow sodium plus influx. Near midpoint of slow depolarization. At this point, T-type channels open, causing calcium 2 plus influx. T-type channels open for a short period of time, and the pacemaker potential is still approaching the threshold. Once threshold is reached, L-type channels open, causing calcium 2 plus influx. When there's calcium 2 plus influx seen because of L-type channels opening, this is rapid depolarization. That's the first event of action potential. The second event of action potential starts when L-type channels, which are open to rapid depolarization, closes and rectifier or K plus rectifier channels open, causing K plus to move out of the SA node. And that is repolarization, which is the second phase of action potential. I took this picture from this link over here, so the credit goes to the link. Thank you for watching the video.